So this will be our regular routine, no? I will be calling the attendance first thing in the morning, and then after that I will start the recording, no? Our sessions will be recorded and will be uploaded to YouTube, and I will put a link, okay, of all our sessions, recorded sessions in Daigler. If you look at, have you opened your Daigler class lately? So I already had a meeting of the other sections rather yesterday. No, so there's an you're free to look at any session you like, okay, but the topics will still be the same, okay. There's a syllabus, you can download them. Yeah, you can download it, and then anyway it has the same set of topics on our Daigler site, okay, our Daigler class. This is CS1130, which is introduction to computing. What is this course all about? This is a sneak preview of many of your subjects which you will take up in the future as you go through the CSD, Computer Studies Division of the Ateneo de Davao University. Okay, they follow sneak preview ito, which means that it is a collection of introductory topics, okay, from all other courses, many of which you will take up again in detail, no, in your later years. No? So our main coverage will be history of computing, no, and then we will have introduction to computer hardware and computer architecture. You will have also digital, by the way, digital representation, numeric system conversion, and then digital design. We will use a simple software called uh, we'll use a software for simulation, no? And creating circuits, no? In digital design, okay, later, no, which you will download. And then you will have a computer structure of computers, CPUs, no, and then you also have a little programming. You will have HTML and JavaScript. If you have time, we'll take up a simple courses on databases. Okay, am I clear on here? No? So this is an introductory course which will introduce you to the different field of specialization which you will later take up in your succeeding years, no? Even until you reach fourth year, no? Like this semester I'm handling a fourth year class which who are taking up digital design, okay, they follow. So introduction to computing, so this is the very basic course required for all students of the computer studies division regardless of what major you are taking up, okay. Any questions? So I presume you have logged into our Daigler class, no? So if you have no questions, we will proceed to the first topic. Okay. This is introduction to computing, no? I'm sorry. Sorry, no? Sorry, I have to set this. I haven't set it up. Okay. Anyway, no. I'm sorry about the annoyance. No? So this is introduction to computing, and then the first topic is history of computing. Okay. Now, what is the importance of history? Why is there always history? No, if you have math, no, if you have engineering, you will have history of engineering, and teachers will always give you a background, no, of the subject by introducing its history. Why is it important? Okay, anyone? What is the impact of history in any, no, subject area? Well, it's very important, especially in computer science, no, and computer architecture, because one of your main objectives is to understand the structure of a modern computer, right? Diba? You need to have an understanding of the structure of a modern computer. It's like, describing the system of an automobile, no? What if you are asked by someone to describe the structure of a modern automobile? Can you do that? Shall we say if you're asked to describe in detail the structure of a modern CPU, Okay, like the Core i3 or Core i7, can you do that? It's difficult. Why? Because the structure as of the moment and its current status is very complicated, right? We can't do that in a month or in a maybe not even in a semester. So one way to understand the structure of a system is to study its evolution, how it evolved and how it came to be, right? Because most items or most technological developments, most developments in technology started from simple things. Do you follow? Like the automobile started from a simple wheel, right? The computer started from a simple calculator. Do you follow? So our objective in studying the history of computing is not just to mention the events, but we will look at the structure of the different computers that were considered significant in the development, okay, in the long and arduous development process. Do you follow? No? In fact, when we are going to study the structure of a certain computer, we are going to more or less simulate a program that will run into it, no, using Excel. Do you follow? By the way, before I forget, no, you will have the basis of your grade will be formative and performance assessments. No, 70-30 tayo dito, no. Formative assessments are those you take online, and performance assessments are your programming assignments, no? And circuits that you will create, for example, and then your problems that the solve, no. These are performance assessments. Okay, 70-30 tayo dito. Your 70% of your formative assessment will make up your grade, and 30% from your performance assessment will make up your grade. Okay, sorry, I forgot that earlier. Okay. By the way, our session, no, schedule also is posted in our daily site. So that's what we are going to do. We are going to, if you look at our no, we will be studying the different structures of the significant computers that were developed in history, and we will try to understand the structure and possibly create right programs on them. Of course, you will not be programming those computers anymore, no, because they're gone, long gone, no. But it will help us understand the structure of the next upgrade. Ganyan talaga yan, no. We start simple and then we go upgrade by upgrade until we reach to the modern and complex system. Okay. Any questions so far? Okay. So history of computing. When you say history of computing, you're not talking just of computers, but also all relevant technology related to computers, no? Like the mathematics, no? The recording media. Kasi in computing technology, you will have the physical technology, no? Machine and electronics. And you will have the recording technology, the data representation, how data is recorded. So they always come hand in hand. The machine and the data that is used to run it. Okay? They follow? So we will study the development of both aspects. Okay? Anyway, so history of computing, two main factors tayo dito, no? We have the mechanical computers and the programs that are used to run on them, and the data representation. The very first significant events in history of computing can be traced in the early modern period in history. Because history is divided into different periods, di ba? We have the Bronze Era or Bronze Age. Then you have the Iron Age. And then after which you have the Roman Empire. It's about a millennia, no? The age of the Roman Empire. And after which you will have the Dark Ages or the Medieval Ages. The medieval ages was the period right after the fall of the Roman Empire. Why are they called Dark Ages? Because during the Roman Empire, so much development in the field of engineering and technology occurred. You follow? The invention of the wheel, the invention of the weapons used by the Roman soldiers, the catapult, engineering, no, the aqueducts, no, in civil and mechanical engineering, kasi wala pa namang masyado electronics during those times. Okay, so the age of the Roman Empire is considered to be one of the golden ages in technology, no. particularly science and engineering and mathematics. But when the Roman Empire fell, okay, the world came into a stagnant period in terms of technology. Not so much happened. Okay? Diba? Wala masyadong nangyari. And then, diba, one millennia. So, that's 1,000 years of Roman Empire. Now, in 1642, that's the early modern period. That's the 17th century. There was the first significant event or development in the computing history came about in France. Before that, the main mechanical tool for computing is the abacus, diba? You follow? Will you excuse me a while now? Dali lang na. Hello? Yes. Yes, Annie? Sir, I'm very sorry. I'm still in class. Can I call you later? Oo, kaya. But anyway, I'll call you later ng mga 11 o'clock. Okay, thanks for calling. Okay. Thank you. Thanks for calling. Okay. It's okay, sir. It's okay. Hindi ko pala na-mute. I'm sorry. Sorry, hindi ko na-mute na. I'm sorry for the disturbance. Anyway. So, before the modern period, the only computing tool was the abacus. Do you know how to use the abacus? Everyone? Who knows how to use the abacus? You don't care anymore, no? Anyway, the abacus works in this way, no? You have this. Okay. Ito, what is this? The beads of tens. The beads of tens. This is the beads of 5. Okay. So when you count, you move beads to the left to count up. You move beads to the right to count down. If you count up, you move this one. That is 1, 2, 3, 4, 5. And if you want to have 6, you move this 1, 5, and this is 1. This one again. That makes 6. To make 11, okay, you will move this one and move this one. That's 11. Okay. Do you follow? No. Simple, but a very simple concept, no? But this is used later also in the other developments. Okay. Do you follow? Like the first, significant invention after the abacus is the mechanical calculator, called Pascalins by Blaise Pascal in France. 1642. They are called Pascalins. Now, let's look at the Pascalin. Instead of using beads, to represent 5 and 10, 5 and 1s, a Pascalin uses rotating gears. Do you follow? Diba? I-shift mo yung left and right for the beads in an abacus. Okay? Dito, you rotate gears like an odometer in a gasoline station. Like for example, to count up, you move counterclockwise. The beads can have 10 different symbols, 0 to 9. So now counterclockwise, kasi 1, 2, clockwise will count up, counterclockwise will count down. Okay? Okay. You follow? And then the first wheel is the wheel for, the first wheel here is the wheel for the ones. Is the wheel for the tens, the wheel for the hundreds, the thousands, and the, okay? So you will be able to do subtraction and addition using the Pascalin. So instead of using beads, so you can see the evolution already, beads were replaced by rotating gears. They follow, but the concept is still the same because it's much easier to rotate a gear than to push a bead, bead. They follow, di ba? Madali mag-rotate, So walang keyboard, so you have to rotate. Okay. Any questions? So that's the Pascalin. Okay. This was invented by Blaise Pascal. Now, it's important to note, that the early developments of computing almost all of them came from Europe. Okay. Europe was the early source of developments in the computing technology. But in the modern period, most of the development shifted to the US. The US na. Like for example, Blaise Pascal is from France, Van Leibniz is from Germany, Jacquard is from France again, Thomas de Colmar is from France, and then Charles Babbage from Great Britain, and Augusta King also from Great Britain. And Hermann Hollerith is an American. Okay. So the next important invention after the Pascaline is the step reckoner. Okay, step reckoner. If you look at them, they're just almost the same, no? Step reckoner by Gottfried von Leibniz from Germany, no? 1673. This is late 17th century. No? So if you look at the, no, this is the step reckoner. It looks almost the same as it's very similar to the Pascaline. Okay, they follow. Kaya lang it has more gears and it has a crank. Pag crank mo, all gears will set accordingly. No? The crank is like the enter key. No? In a modern computer, you input one computer and you press enter. You input one number, you press enter. Here you switch the gears and then you crank. Switch the gear and choose up an operation. You crank and you get the result. You follow? No. So the main difference between Pascaline and step reckoner was the step reckoner can now do multiplication, and it was now using binary numbers inside, no? Kasi ang the Pascaline are using decimal numbers. Okay? Okay. Now, in the early 19th century, 1800s, a development in recording technology occurred. How to record. Joseph Marie Jacquard from France invented a recording device that can be used to save, like memory, right? To save values into a punch card, in a wooden punch card. It's called a Jacquard loom. Can somebody tell me how this thing works? Jacquard loom. What is a loom? A loom is a machine, mechanical, no? It's a machine that is used to weave fabric. They follow? Okay? Like this, no? It's a Jacquard loom. So, how is it significant in the recording technology? During those times, meron bang kuryente? When did electricity? Benjamin Franklin? 1900 yata eh. Benjamin Franklin, 1752. Okay. But was it industrially used? Electricity used in Europe. Remember that electricity was discovered in the US. Anyway, let's not go through that. It's not important anyway. So the Jacquard loom, there's no electrical power in Europe. So most of the devices are mechanical. Okay. The thing is, how was it able to record? Because when you weave fabric, the design patterns are stored in a set of wooden cards, where the wooden cards contain holes, okay, corresponding to the design that is being woven. Do you follow? Ganon. So Joseph Marie Jacquard invented in such a way that the machine will be able to record decimal values, by the way, on a punch card by designating a digit with a sequence of holes. So a different set, one corresponds to a particular hole, two corresponds to another particular hole. All some symbols correspond to a unique set of holes. That's how they are being recorded. Now, how are numbers read? Now, that's when the loom is used. Now, the card is put under a loom and the threads are allowed to pass through the holes in the card. the holes in the card. Whatever patterns come out of the loom will indicate the number that is stored in the card. Okay? Do you follow? So here's a Jacquard loom, another Jacquard loom. Okay, so ito yung mga looms. They will scan. There's a scanner, no? Mechanical scanner that will scan the card and will let the loom pass through. And whatever sequence was generated by the loom will be reflected as the corresponding value that is stored. Do you follow? So this is called the Jacquard loom. This is like the first hard disk that was ever invented. A card can store several decimal values. Okay. Okay. So Jacquard, no? Joseph Marie Jacquard. Thomas de Colmar, also in the early 19th century from France, invented an upgrade of the step reckoner from 1851 to 1915, which became commercially successful. No, it was sold as a mechanical calculator. Okay, it's called the arithmeter. No? It's a mechanical calculator because it can perform all operations. No? Kasi ang arithmeter hanggang multiplication lang. Shading. Yeah. Yung sa voting ngayon, di ba? From this is Makabangon. When you vote, you shade. Those times you don't shade but you punch holes, no? Into the So it's a very long and tedious process, no? Yung Jacquard loom. So this is the arithmeter, no? It's similar to a step reckoner. Meron din siyang crank, no? Dito na sa right side, meron din siyang crank. But this time, no, it can also do division. Okay? Yung yung step reckoner can do multiplication by repeated addition. Okay? Any questions so far? Okay. So Thomas de Colmar invented the arithmeter, the first commercially sold mechanical calculator. No? Okay. Also about at the same time. Now, who invented the first computer? Charles Babbage from Great Britain. You follow? In 1822, he came up with an invention called the differential engine. Differential engine, okay? This is used to tabulate. This is used to calculate rather polynomials. Ito. Look at that, no? It also uses the concept of gears, no? Where one gear can store 10 symbols, no? Kasi decimal ito, no? They follow? It's not binary. Okay? Which was later discarded, no? It was never used, no? So my cranking handle din, it also has a cranking handle. And then in 1837, he came up with a very distinct invention. It's nowadays we're considered to be the first computer. It's called the analytical engine. Okay? Considered to be the first mechanical general purpose computer. He is now considered to be the father of contemporary computers. Okay? The father of modern computers is John von Neumann, and the father of modern computing technology is Alan Turing. Okay, we'll take them up later. Now, what was the invention all about? The analytical engine. Here's the analytical engine. Okay. It is an invention different from the mechanical calculators because it uses two sets of input, no? An instruction and data. Do you follow? And then there are two parts, the mill and the store. No? So the mill is actually a set, the store is a set of punch cards using the Jacquard loom. Wala na dito yung the store, no? This is just the mill. Tawag niya doon, the mill and the store is a set of Jacquard loom that scans a set of cards. The Jacquard loom contains the program, and then the mill is actually the CPU which processes the instruction one by one. Do you follow? Okay. It's a decimal mechanical computer based on decimal numbers. No? During those times, no? Nobody understood Charles Babbage. He came from Cambridge University, right? Yes. He's a mathematician, an inventor from Cambridge University. Okay. Actually, the differential engine and the electrical engine were government-funded projects. No? The funding stopped later, so he was not fully successful. No? And his invention was usually or discarded among the scientific and engineering community in this university because nobody understood the use of such an invention. Okay? Ayaw ng mga tao, ayaw ng mga scientists. However, one mathematician, also from Great Britain, also from Cambridge University, came across his research and reviewed his output and came up with a recognition of the machine as a machine that is useful for mathematical applications during those times. Okay, so the mathematician was Augusta Ada King, Countess of Lovelace, no? From Great Britain. Do you follow? They were both mathematicians, although Ada King was a lot younger. No? She died very early, no? At age 41. Okay. What Ada King did was demonstrate the application of the invention of Charles Babbage. He demonstrated that certain algorithms can be carried out by the machine. They follow. In fact, one of the programs that he wrote is still there among the books, no, of Charles Babbage. No, it's called the Bernoulli application. No? Given a number n, what is the n series in the Bernoulli series? So the Bernoulli application is actually a full polynomial expression which is applied, no? It's just a lot of applications in mathematics, no? In our case, we'll try to demonstrate it with using much simpler computations, no? She was able to demonstrate. We'll have that, no? May programs yung ginawa. Si Ada King, the Countess of Lovelace, demonstrated and wrote a program to run the analytical engine. Nandito yan, no? Okay. Nandito ang link. There's a link in our regular site. Ayan si Augusta King. There's no photo yet, so they have to. This is the program written. This is instruction 1, instruction 2. This is the command, and this is the parameters to the command. Okay, you have a set of variables which are used as the parameters, and you have a result for variable. This is the program written by Ada King on the analytical engine by Charles Babbage. Do you follow? So during those times, it was called algorithms to be carried out by the analytical engine. Nowadays, it's recognized to be a set of instructions qualified to be recognized as a computer program. So Ada Augusta King is now considered to be the first computer programmer. You follow? No? So who invented the first computer? Is Charles Babbage. It's a decimal computer. Who programmed the first computer? Augusta Ada King, the first computer programmer. Okay? We look at the analytical engine in greater detail. No? Later, no? We will write programs on based on the instruction set of the analytical engine. We'll also compare it with other computers. Okay? Later, no? Popular computers in the computing history. Okay? Okay, any questions so far? Now, also on the same century, in the 19th century, later, no, in the U.S., no, Herman Hollerith made an improvement of the Jacquard's loom, you know, because electricity was already available during those times, no. So he invented an upgrade of the Descartes loom, which uses punch card tabulating machines to store numbers on a punch card. And it's very popular. It has been in use even after the Second World War to be the formal recording media for computers during those times. It's called the punch card tabulating machine. This was used originally for the US Census. You follow? So punch card tabulating machine. Let's look that up. Herman Hollerith. Nowadays, you can only see these machines in a museum. Ito. Okay, so look at that. The set of cards are are stored in a cabinet. Instead of using looms, it now uses electromechanical machines. Electromagnetic na ito. To be able to do the punching and the reading of cards. Do you follow in a sequence? Okay. Do you follow? Who is Herman Hollerith? Aside from the inventor of the punch card, he is also the founder of a very large company, a tech giant, which is still around nowadays. What's the tech giant? Founded by Herman Hollerith. Anyone? What's the tech giant? IBM. Yes. Tama. Clyde Macabangon, IBM. So let's look at IBM punch card. How does the IBM punch card look like? Ito yon. Okay? Ito yon, no? So there are 80 columns in the punch card. So each column can store one digit. Do you follow? Depending on where the punch is. For example, if there's a punch here, that's number 1. If there's a punch here, that's number 2. Do you follow? So the number 20 is a punch here, not punch there. A punch there. 0. See, dito yung 0, Do you follow? Okay. Now, can it store letters? Later it was used to store letters, using the IBM representation, Do you follow? So Herman Hollerith, invented the punch card. He also founded later IBM, which was the tech giant for a very long time. It's like Microsoft and Google or Facebook. The earliest, the first tech giant, Herman Hollerith in 1884. Okay? Do you follow? Next meeting, that will be up for now, For the moment. Next meeting, we will look at in greater detail the structure of the computer discovered or invented by Charles Babbage. Okay, and let's look at what programs can be run on them. Simple programs, on these machines. Okay? Any questions? Class? No? For the wala tayong lab schedule, Did you pay? Can you check your SIS account? Check if you have paid a computer lab fee, because my son who's enrolled in a multimedia course in a different division was collected computer lab fee. Kasi if you are most probably will be doing face-to-face sessions later, as of the moment there's no guideline yet on how we will do face-to-face classes, but in my consultations with other faculty members and with the department also, in our previous meetings, most probably the face-to-face classes for us for computer studies will happen during lab schedule. We follow. Our lectures will remain to be online. Okay, yung lab activities maybe the first sessions for face-to-face classes. Okay? Any questions? Wala pang guideline, but most probably we will do later when face-to-face sessions are I understand in the presentation by the AVP, during the orientation, they have created a certain type of classrooms designed for physical presence and online presence of students participating in a class. In our case, I think a computer lab will do that, because we can have several cameras running together, run on the same PC. I'm doing that myself, so that others who are from remote places can participate online. Okay. Any questions so far? So, yung meeting natin twice a week, no? TTH tayo, 9, it's in Dagler, no? By the way, no? 9:20 to what time? For the moment, we'll end early, no? 9:20 to 10:50. It's just 10 a.m. Do you follow? Twice a week. You will use your lab time. Last year, the university did not charge any lab fee, so we had no issue on performing lab sessions. You do your exercises during lab time, but the face-to-face sessions will have to remain withheld, okay, for the moment. Okay. Did I miss anyone? Any latecomers? For this 100 tayo, no? Advincula. Is this correct? For this 100 ba? Yes. Are you there?
Yes, sir.
Yes. Can you show me your camera, Jemris? Where are you from?
Sir.
Where are you from? Where are you based?
Davao, sir.
Davao, okay. Can you show me your camera?
Yes, sir. Sir, hindi mo remember, sir? Nagpunta man ako sa birthday ni Z, sir.
Okay. So you are the matinee idol from the senior high school, right? Am I correct? No? Jemris is the matinee idol of the senior high. You didn't have face-to-face classes during senior high. Okay? But thank you for coming anyway. Francis Fabila.
Present, sir.
Okay, can you show me your camera? Francis, where are you from?
From Midsayap, sir.
You're currently there?
Yes, sir.
Okay. How is the internet in Midsayap?
Now, sir, it's good na, sir. Kaya nag-update na sila to fiber optics.
Okay. Anyway, it's not very far, no? Midsayap
Yeah.
is how many? 1 hour or 2 hours away from the Davao City?
4
Okay.
hours, sir.
4 hours?
Yes.
Okay. Midsayap pala, it's a 1 year Arakan, no? Next town? No, Magpit yun. Magpit.
Ano?
Midsayap is right
Cotabato.
before Cotabato City.
Yes, sir.
A few hours, no? 1 hour away from Cotabato City. Is that correct? Yeah. Site Seb Flores. Are you there? Site Seb. Rar Ased Morandante. Late enrollee to si Morandante, no? AJ Tolio, meron yata sir 8 to. Yes, we have a session. I'm sorry, but the session on Friday is the lab session, okay? Wala pa si Morandante. AJ Tolio is here. AJ ba? AJ, no?
AJ, sir.
Yes,
Hello.
where are you from, AJ?
Currently nasa Davao po.
Okay, you will be based here?
Yes po.
Okay, anyway. Thank you, no? Anyone else? Wala tayong Friday, no? But because it's reserved for lab, you'll use it to, kasi dapat gagamit kayo ng lab, ng computer lab if you are paying lab fees, okay? But anyway, let us withhold that for the moment, no? Okay. Okay. So any more questions? That will be up for today, no? And then next meeting we'll proceed to more topics. No assignment for the moment. But there will be, several assignments coming up.
Sir, twice a week man ang class. Sir.
Come again, I don't hear you. Sino ito?
Twice, ako, Labrador po.
Labrador. Can you just chat na lang? Kasi mahina yung boses mo eh. Sige. Labrador, Tony. Twice a week po tayo mag-meet sa Zoom. Yes, twice a week. We'll meet twice a week in Zoom. It's in our regular no. Nandito sa assignment. Our Zoom meeting and room and schedule. So this is CS 400 every Tuesdays and Thursdays at 9:20 a.m. to 10:50 a.m. Okay? Do you follow? So anything else? So this session will be recorded, no, and will be uploaded like the previous ones, no. I hope you are able to find the link, no? Nandito yung link, okay? I'll usually put the date and the section and the topic being discussed, okay? You find it there. I think I'll be able to upload this by lunch break, okay? Before lunch. Any questions? Anything else? Now, attendance is not yet a must, no, for online classes. No? That's a policy, but I always check attendance to find out if students are still attending classes. Kasi mahirap magbigay ng grade na hindi naman hindi pumapasok. Okay? Attendance is not required for online classes. No? So if you miss a class, you can view the class in YouTube. Okay. Anything else? So thanks for coming. No, I record this and see you next time. Next time is Tuesday. Okay. Wala tayong meet sa Friday, no? Okay. No Fridays. It will be reserved for lab schedule, lab activities.
Hi,
Okay.
sir.
Yes.
Ito na yung official Zoom Meet link.
Yes.
natin.
Yes. But it may change, no, because I am subscribing to one, no. It may change. I will email you if there's a change, and I will also post a change in Legler. Okay.
Okay, sir. Thank you.
Okay. Anything else?
Sir, excuse me.
Yes. German.
Present po ako, sir. Galing lang ng CR.
Okay. Reason. Where are you from, German? German ba? Herman.
German, sir.
German. Where are you from?
San Fran, sir. Agusan del Sur.
So you're in San Francisco now currently?
I'm in Davao, sir.
Where will you be? Ay, tag ko lang, San Francisco, no?
Thank you, sir.
Okay. So, see you then, no? On Tuesday. Bye, everyone.
Thank you, sir.
Okay, thank you.
Bye, sir. Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you, sir.
Thank you,
Yes,
sir.
sir.